So it's my pleasure to welcome all the YouthMappers and friends and family and extended YouthMappers family to the session today. We're really excited to have this opportunity to speak with you and introduce this really exciting project that I think you guys are going to love supporting. So we'll introduce the three organizations behind this event, and then we'll get into the nitty-gritty, learning more about it, and we'll have some time to actually come together in breakout rooms and do a little mapping. So without further ado, I'd like to kick it over to our friends and colleagues over at UNICEF Giga.
Okay, hi everyone. First of all, let me briefly introduce about our initiative Giga. So my name is Do-Young Kim. I'm a lead data scientist at Giga Initiative. So Giga Initiative is a partnership, joint partnership between UNICEF and ITU. And together we are actually aiming at providing internet connectivity to the schools which doesn't have internet connectivity. So I'm leading this small group of the data scientists, and working mostly on gathering school location data and the coverage information, etc., and also other data science related projects to support the Giga's operation. So I'm here with my colleague Oz, joining from ITU side. So hope that he can introduce himself. Oz. You are on mute, Oz.
No, we can't hear you, Oz.
Hear me now? Yes,
Yes.
perfect. Hello, greetings from Istanbul. My name is Oz. I'm working as a mapping officer for Giga Initiative from ITU side. And most of the time I'm working for the geospatial tasks, some data collection effort, and doing some GIS related work. Welcome, everyone.
Wonderful. Thank you so much. We will also do a brief introduction to YouthMappers. I know many of you are familiar with it and are active members of our network, but for those who aren't, my name is Courtney Clark. I'm the program director of the Everywhere She Maps program for YouthMappers, and I'm joined by my colleague Marcella. You want to introduce yourself as well?
Hi, everyone. Good morning. I'm tuning in from Seattle, Washington in the US. My name is Marcela Ceballos, and I'm the managing director for YouthMappers.
Wonderful. So YouthMappers is a global network of 327 university chapters in 67 different countries. We're growing weekly, constantly adding new chapters, and we're a global community of students, researchers, educators, and scholars who use public geospatial technologies, including OpenStreetMap, but also other tech, to highlight and directly address development challenges worldwide. Students, such as many of yourselves, are really at the center of everything that we do, and we aim to empower you to decide how and where you want to put yourselves and your communities on the map. We were founded by a coalition of organizations, including USAID, as well as Texas Tech University, George Washington University, West Virginia, and Arizona State. We're also able to do our work through the support and partnership of a lot of wonderful organizations, including UNICEF and Giga, but also the partners that we have listed here, we work really closely with. So we like to show this just to really emphasize that YouthMappers is truly a network and a really strong community within the OpenStreetMap broader community.
Thanks, Courtney. And I'd like to highlight how chapters participate in many ways by organizing remote campaigns or executing local mapping activities. YouthMappers really integrate knowledge from their university coursework with the technical skills they learn through participating in our training and fellowship programs and apply it directly to real-world humanitarian and development projects. Remote contributions happen collectively at virtual mapathons or through individual contributions to projects organized on the different platforms, much like the challenge that we are going to contribute to on MapRoulette today. Our motto is, we don't just build maps, we build mappers. And through our different fellowship programs, the Youth Mappers Academy, our fieldwork program, mini grants, Everywhere She Maps, and the Regional Ambassador Program, we are able to support students' abilities to create and share knowledge while building community and generating high quality data. So thank you again for joining us today.
Cool. Yeah, thanks, Marcel and Courtney. My name is Rory Nealon, and I'm based in Baltimore in the United States, where it is really rainy because we have the last remnants of Hurricane Ian dumping a lot of rain on us. But I'm going to talk about where I work, USAID. Next slide, please. In 1961, USAID was founded by John F. Kennedy to be the lead organization for the US government's international development and humanitarian efforts. It had been kind of dispersed through a bunch of different offices before then. And USAID aims to promote broad human scale progress and to promote stable free societies, which creates markets and trade partners for the US, and also to foster goodwill. We work in over 100 countries where we work on global health, peace and security issues, humanitarian assistance, and we also try to catalyze innovation and partnerships, as well as empower women and girls. In this picture here, you can see my big boss, Samantha Power, who leads the agency. Next slide, please. Then where I work at USAID is a team called the Geo Center, where all the kind of geography and mapping is housed at USAID, or most of it. And so it was formed in 2011, and we're data scientists, geographers, and analysts, and we work with all the different offices at USAID. So the DC ones, which are focused on more domains like agriculture, health, and gender issues, but also with our offices out in different countries, which are focused more geographically on the countries and regions they work in. So what do we actually do? Well, we support geospatial mapping and analysis and visualization. We create custom products for these different offices. We help train them on different geospatial skills, including analysis and visualization, and utilizing different geospatial data sets. We have a remote sensing program where we provide different programs and offices with high resolution Maxar satellite imagery. And this is also available to YouthMappers too. If you're working on a YouthMappers project, we can discuss the possibility of supporting, no guarantee, some satellite imagery. And then we also support the YouthMappers program, which is a big part of what we call digital development, trying to work on the digital skills divide and the digital data divide. So improving the amount of data that's housed in the country to help foster economic growth, but also trying to transfer a lot of the skills to locals in that country, such as yourselves, to be able to do a lot of the work there. And looking forward to learning more about this Giga project. Over.
Okay, thank you for the nice introduction about the YouthMappers and USAID. So let us briefly introduce about our effort to map the school locations using AI and satellite imagery, which is a background and context for this collaboration based on this crowd mapping effort. So again, my name is Do-Hyung Kim, and people call me Do for the simplicity. And then, yeah, let's move to the next slide. So as I briefly introduced, the Giga initiative is a joint initiative between UNICEF and ITU, aiming at providing internet connectivity to every school in the world. Next, please. So to support these operations and purpose of the Giga initiative, we have been collecting this information, the baseline information about, you know, the locations of the schools and the internet connectivity status for each individual school. So this is an example of the data that we have gathered for Brazil and ingested to our web-based platform called Project Connect. So you can see that red dots and green dots here, but the red dots indicate the schools locations without internet, while green dots indicates the schools with the internet connectivity. So you can imagine the kind of digital divide that these two schools would have, and the loss of the chances to access to opportunity that internet can provide to those students and children. Next, please. So based on those base information that we're gathering, we've been working hard to work with the collaborators and partners to provide the internet connectivity to the schools since 2019, when the Giga initiative started. So far we have connected more than 3,000 schools, which is more than 1.3 million students providing internet connectivity. And we also have been working to map the school locations. Now we passed the 1.1 million mark in terms of the numbers of the school mapped in our Project Connect platform. Next, please. So let me briefly talk more about this mapping school locations. So when we start this project, Giga initiative in individual countries, we first work with the Ministry of Education or government department and the UNICEF country office to identify and gather the existing school location data and some attribute related to the schools. So if we don't have like very comprehensive data, sometimes we carry on some field campaign, like sending people to actually collect this information on the ground. But in many cases, that is not feasible. For example, in Sudan, the political situation is not quite stable, and the financial situation is not really enough to plan this kind of field campaign. So for Sudan, we had to plan some alternative. So this is using AI and satellite imagery to map the school locations out of it. So for Sudan, we have developed like a different method, and finally we developed some working solution using object-based detection method. So based on this success, we are proceeding with the crowd mapping validation projects, and also to build a scalable approach. Next, please. So let me briefly talk about this Sudan project specifically. So this is a collaboration between UNICEF Sudan country office and Giga initiative. And as you can see in the figure, the original data given to us from Sudan country office was not really in a high quality. So you can see that many of those school locations provided to us lies outside of the Sudan country boundary. So we have to first clean this data, and then just 6,000 school location lies within the country boundary, and then we manually validated those school locations to leave just 2,000 school location identified and verified. So we used this information to develop this machine learning algorithm. Next, please. So let me talk about briefly about this AI model development approach and effort that we made. Next, please. So first of all, we use these resources from U.S. State Department. It's a MapRoulette project, and we could through this collaboration, we could get access to this globally available high-resolution data set, and also through our partner Dell, we could gather some good computing resources. Next, please. So using this resource, we developed this AI model, which is capable of identify the boundary of school. So within this satellite imagery, we could actually pinpoint the actual locations of the school using this model called object detection model. Next, please. So this is some details about this model development, but we achieved more or less 90% of accuracy using the final model that we have developed. And briefly assessing this model, we were satisfied and move on to apply that to the entire Sudan area. Next, please. So that's where we actually face some problem, because the Sudan is a very large country. So we first split the entire country into some grid cells with like 1,000 by 1,000 pixels, which is like 600 meter image tiles grid. So we end up have like 5.6 million image tiles to download. So this was too huge. So we just used the settlement data or building layer from Google and the European Commission to reduce the image tiles into 1.2 million grid cells. Next, please. And then we applied our object-based model onto 1.2 million tiles. And next, please. As a result, you can see little more than 20,000 schools are predicted colored in red in the figure out of this 1.2 million satellite imagery tiles colored in blue. Next, please. So this is a huge reduction from 1.2 million tile to 20,000 tile when it comes to the manual validation. So we don't really have to go through all this 1.2 million tiles. Instead, we just go through 20,000 tiles to validate and confirm that it is actually this code that we are making predictions. So this is a kind of result that we have seen in some of the region in Sudan. So you can see that red dots are actual schools that we validated ourselves, and the yellow dots are the school location predicted by our model. And also you can see on the right corner that some known pattern of the school buildings are accurately identified. Next, please. So these are some results showing that the green dots are accurately picking up those individual school instead of just identifying those cluster school as one, which is the original data does, colored in red. Next, please. And also our model could flag this false information from the original data set, which indicate a school location in the desert area. Next, please. And finally, our model actually adds the precision to this location information. So compared to the original data set colored in red, you can see that green dots are more accurately located within the school compound. Next, please. So let me briefly talk about our next steps and direction. Next, please. So we are now setting this cloud mapping-based validation onto this some sampled locations out of 20,000 school locations that we predicted using this model. Next, please. And also we are starting the similar project in Brazil to increase the accuracy and precision of the location data that the original school location data that Brazil government provides. Next, please. Yeah, that was about our project to use the AI algorithm to produce these 20,000 school locations, and also we'll talk more about this MapRoulette platform out of this prediction. Thank you.
Yeah, thank you, Joe. I think after that I can share my screen. Yes, thank you. So before we start, to give you an overview, I will first talk about MapRoulette, what it is and how we can use it, and then I will give you an overview about the step-by-step validation process, and I will give you one walkthrough how we can use it on one example task, and then we can start for mapping or validation. Okay, let me share my screen. Okay, can you see it?
Yes, we can. Thank you.
Thank you. Well, doing this, let me share the links before I share my screen because I cannot see the chat. In this case, this is the MapRoulette's website URL that we will use today. And this is the challenge, the school validation task that we are going to validate. Okay. So the MapRoulette is a micro tasking management tool just for OpenStreetMap. In this way, we can validate some data sets in OpenStreetMap and then increase the data quality. It is quite fully integrated to OpenStreetMap. You just need to click on the sign in button on the upper right hand side, and it will ask you for the authorization, which is directly linked for your OpenStreetMap account. You just need to give the grant access and then just open it. Once you sign in, you can click on the second link that I shared in the chat that will redirect you on the Sudan school mapping task, which seems like in this way, in user interface, we have around 1,000 tasks in this challenge, and each task averagely takes 2-3 minutes. So you can just click on the start, or you can select by zooming in on the map. Once you click on the start, there's an instructions part on the left-hand side. So I'm going to walk through on this part first. There are 4 main steps to validate or map the school data. The first one is selecting the true imagery. We will use Maxar Premium imagery, and I will show you this one, how you can change the imagery and background. And the second one, we will trace the school area. We will create a polygon and then add tags that we are going to use to specify the geometry that we created as an educational area or school ground. And finally, we will save and upload the tank set and then move on to the next one. So before we go on the walkthrough, I would like to show you the patterns of the schools in Sudan. In this way, we will much more familiarized with how the schools look like in the country. Let me share my screen again. I will also share with you the link of this document that has some screenshots about the buildings, school buildings. You can also find it in the instructions. Okay, so the most common school structures in Sudan is the parallel bars one. The number can change, but most of the time the schools are parallel against direction. You can find them in both rural and urban areas. The first one is two parallel bars like these buildings. It can be with fence or without fence. The second most common one is this one. One is much more longer than the other. As you can see here, on the left one has some fences around, but the right one doesn't have this attribute. So the other one is the one long and two short one, like this, located. There are some of them are in the four short parts, again aligned and parallel in this way. So I'm not going to go through on each of them, but I will share with you this document. So every time you think that you need to check, you can go back on this document and then check and validate and map the schools. So finally, let me walk through on how we can use MapRoulette and how we can use ID editor to save our edits for this project. But before we go further, I will share with you the link of the document. Yes, here it is. So once you signed in the MapRoulette, you need to go through the second link that will show you our challenge that we are going to map today. And then you need to click on the start button on the right hand. And here you can see some buttons. And this is the selection for your editor. If you're an experienced mapper, you can go through on the JASM or the other ones, but I'm going to introduce on the ID editor one, which is web-based. So as you can see, it gave us to the MapRoulette gave us one random task represented with pinpoint. Once you select in this, you need to click on the edit button. So it redirects us to the OpenStreetMap's ID editor. Are you seeing the ID editor's interface, or are you seeing still the MapRoulette's interface?
We can see ID editor.
Perfect. So as you can see, there's a background with an imagery here. First, we need to check what if we are in the true background. So here, as you can see, there's a button that called background settings. You need to click on this, and then you should check if we are on the true one. If it's not, you should go through on the Maxar Premium. And if you would like to compare between the other imageries, you can select the other ones as well. For instance, here you can see the map box as well. We will go through on the Maxar because it has the much more resolution than the others, and it's much more up to date than the other. So once we are done with this, I'm going to briefly talk about the data structure of OpenStreetMap. There are three geometric data types in OpenStreetMap. The first one is point, second one is line, and the third one is area. With points, you can represent point of interests, such as like shops, schools, and this kind of point of interest things. And with lines, you can represent the road, rivers, and finally the area, which is a polygon. You can represent land use areas, administrative boundaries of the country, for instance, or forest areas. Today, we are going to use the third one to trace the educational area or the school buildings. So as you can see, this looks like our pattern in the document that I shared with you. First, you need to click the area to trace the geometry. You just need to add nodes for each meaningful corner of the building. And then once you feel done, you can click on the first node, or you can press on the enter button. And as you can see, there are some helpful tags appeared on the left side. If you didn't see school grounds at the first button, you can easily just write on the search bar school, and it gives you the school ground. Once you click on it, now we have the geometry in a triangle, in a square shape, and with a tag of school grounds. We specified the geometry with a tag. Basically, the tags are represented in a key and value. The key here is amenity, and the value is school. Now, this geometry have this tag to represent school. Let's do another one here. Okay, I'm again tracing the school. And then when I'm done, I'm clicking the first node that I created. After that, I am selecting the tag. You can also click on this I button to learn more about this tag. And you can see the documentation, the wiki of OpenStreetMap to learn more about it. If you would like to, sorry, I'm hearing some noise. Okay, I'm tracing another one to finish these tasks. Again, I traced this building. I added the tag. And here you can see we have this all three buildings. You can also right click on any geometry to make it much beautiful. For instance, you can do it much more square. You can also right click on the nodes to delete if you think it's not necessary. Okay, now we have all three geometries with school tags. I would like to introduce you another tag that we are going to use today for each type of geometry that we are going to trace. This is a node tag, so you can add it manually here while pressing on the plus button. This tag will help us to trace all the efforts that we will do today. And then once we extract the geometries that we will trace today, we will use it for our Project Connect website and for our AI. So you can, in the first key part, you can write not, and the second part, you can write Giga check, and then enter. So we have both tags for this geometry, and I will add for this one as well, not Giga check. And lastly, for the third geometry, not Giga check. Once you think that you're done with editing for the task, you can go through on the upper right side to save the edits that you have done. Once you click the save, it shows you on the left side. There are some hashtags in the change set. It's already in default, so you don't need to add anything else. But I would like you to check this button. If you're not experienced mapper, you can press this button to let us know that we can review your edits. And finally, you can press the upload. Now our edits in OpenStreetMap. And
Sorry.
once you are done, yes, please go on.
Sorry, Oz. One thing I would recommend is to add a small note to the change set, just describing what you did. A change set that only has hashtags might get flagged by the OSM Foundation Data Quality Working Group. So I would just recommend writing a very short message saying added 3 school buildings. Thank you.
Yeah, thank you so much, Rory. And once you're done with uploading, sorry, yes, please. Okay, I think it wasn't a question. So once you're done with uploading, you can close the tab, OpenStreetMap tab, and go back to MapRoulette. And you can, if you map the school, you can click on I fixed it. If you think that it's not a school, the task is not a school, you can click on the too hard, can't see. And if you saw that the school is already mapped, you can just click on the already fixed one. Once you click I fixed it, you can add a comment here that I'm just going to repeat what Rory said. 3 school buildings added. And then I'm going to submit it, which will direct me to the next task. So just one more information regarding to this mapping effort. Here you can see there's a fence around the school. So you can also add the geometry and tag it with another tag. Once you click on edit, as you can see, it's already been mapped, the school, but as building, so we can specify it as a school, but we can also add another polygon that traces the fence area, the whole area, but we make sure that not conflict with other geometries. Once you're done, here you can select school grounds again. So this tag can be used for buildings and also for the land use. Once you select this, you will add another tag that is not Giga check. And after that, we can save it. And here we can say added school area. And as again, if you're not an experienced mapper, you can click this and then you can upload, which is done. So if there is any question, I can answer it now, or there is not, we can split into rooms and we can start mapping. Okay, Rory, Marcela, I think we can start mapping since there's, please, Courtney, go on.
Yes, I have a question. Can you please remind us what to do if we're looking at the imagery and we're just not sure if it's a school or not, and we don't feel comfortable tagging it as a school? What should we do?
Yes, actually, I have several examples for this. I select 2 tasks in this challenge. For instance, here, you can see there is a fence around for this building, and there's another fence around for this building. And also, as you can see, there's one road passing by in this buildings area. So I'm not sure if this is a school. Once you select this task, if you granted with this task, you can directly click on the once you say edit, you can go back and click on the two heart can't see without any edit. You can directly say that on MapRoulette and go through on another task. So this is one example, and there's another example here. As you can see, the resolution here is not that enough to trace or identify if it is a school or not. I even not identifying the buildings in this area. So you can do the same. Select too hard, I can't see button again. I hope it's clear, Courtney.
Yes, that's very helpful. Thank you.
Thank you.
We also have a question in the chat that says, hello, I would like to ask a question regarding the feature types that we're going to use. How do we know when to use school building or school grounds?
Let me open the wiki page of this text, and then we can go through together. Okay, let me share my screen. So if you remember the button on the, okay, I didn't fix this one. I will edit. For instance, once you create a geometry here, it was just an example. There's a button near to each of these tags, which shows little explanation. But once you click on the documentation, which will direct you to this wiki tagging page that will show you much more explanation about how to tag. Let's go through on this together. So the first thing that I would like to show you, there are several logos here. The first one means that this tag can be represented with points and also areas. You cannot tag any line feature with this tag. And second thing is, I would like to show you much more detailedly. This is the complete mapping of school area. You can add entrance, yes. You can, if there is any yard that you can identify, you can add leisure schoolyard. Oops. If there is any pitch that you can identify, you can add these tags for them as well. Let me share this wiki page with you, so whenever you think that you need to check, you can find it. The only thing that you cannot find in this page, the node equal Giga check tag, which is special just for this challenge or effort to let us know what is mapped and what is not.